Welcome to qnawire.
We have the following setup in which we have a cannonball that is fired from a mountain that is 100 meters height, aiming at target 500 meters away at the surface as shown below. Find the angle theta 0 and magnitude v0 of the firing velocity to hit the target at 60 degrees. So what is going to occur is that in order for this to hit the target at 60 degrees, what we know is that the ratios of velocities are going to be corresponding to the angles over here. So that means that if we take the tangent of 60 degrees, this would be equal to the velocity, the final velocity on y, and the final velocity on x being the projections on the y and the x-axis. So in this case, tangent corresponds to opposite divided by adjacent, so it would be the final velocity on y divided by the final velocity on x. In this case, we consider that there is going to be no air resistance, so that means that the equation of motion for the velocity of x is going to be equal to a constant. There's going to be no acceleration on x, thus the final velocity on x is going to be equal to the initial velocity on x. Other information that we know is the equations of motions for x as a function of t. For the final time, we wish to have a value of x equal to 500 meters, and this is going to be equal to x0, which is equal to 0, plus initial velocity on x times t. And since there's going to be no acceleration on x, this would be everything that we need to consider. In this case, the x projection corresponds to b0 times, as you wrote down correctly over here, cosine of theta 0 times t. On the other hand, we're going to have that y at the final point needs to be equal to, we can write it down as 0 or as minus 100. Let's label this as 0. And this is going to be equal to y0 plus b0 on y times t plus minus, let's write it down directly with minus gravity, minus 1/2 of gravity times t squared. So over here, what we're going to get is going to be 100 plus b0 sine of theta 0 times t minus 1/2 of gravity times t squared. So these are all of the data that we are going to require in order to solve this problem. Additionally, we may find that the velocity on y as a function of time is going to be equal to my initial velocity minus g times t. So at the final time, we know that the final velocity on y needs to be equal to b0 minus gravity times t final. Let's write it down already that this b0 on y is going to be equal to b0 times sine of theta minus gravity t squared. So now let's begin by employing this condition over here, since this is going to be the angle at which we want to arrive to the target. So tangent of 60 degrees is going to be equal to the final velocity on y, which is b0 times sine of theta 0 minus gravity final time squared over final velocity on x, which is going to be equal to directly b0 times cosine of theta 0. Simplifying this equation, we're going to get tangent of theta 0 minus gravity final time squared over b0 cosine of theta 0. Now the next step is going to be employing the first equation, equation 1. We know that the final time needs to be equal to 500 over b0 cosine of theta 0. So we can employ this final time in order to get our result for any of these scenarios. So let's replace this final time up into equation 2, which now is going to read equation 2. Let's label that this comes from equation 1. In equation 2, we know that y for t final is going to be 0 equal to 100 plus b0 sine of theta 0 times the final time, which is 500 over b0 cosine of theta 0 minus 1/2 of gravity times the final time squared, which in this case is going to be 500 over b0 cosine of theta 0 squared. Now let's simplify this equation. b0 and b0 cancel out, sine and cosine gives us tangent, so 0 is going to be equal to 100 plus 500 times the tangent of theta naught minus 1/2 of g times 500 over b0 cosine of theta naught squared. But guess what? Oh, before we continue, I just realized over here a typo. It should be TF, not TF squared, also here, coming from this equation. So now what we're going to do is replace the value of tangent of theta naught, since we have the result over here directly. As you can see, we know that tangent of theta naught is going to be equal to g times t final over b0 cosine of theta 0. So from equation 3, the condition on the angle of arrival, we know that tangent of theta naught is going to be equal to tangent of 60 degrees plus gravity times time final, which is 500 over b0 cosine of theta 0. And this cosine of theta 0 needs to be squared since it's going to be multiplied by itself. So now our equation becomes 0 is going to be equal to 100 plus 500 times the tangent. So 500 times tangent of 60 degrees plus 500 squared over b0 cosine of theta 0 squared times g minus 1/2 of g times 500 squared over b0 cosine of theta 0 squared. Notice that over here we have simplified our equation a lot, and we're going to have something that only depends on b0 cosine of theta 0. So our result is that now our equation simplifies as 0, 100 plus 500 times tangent of 60 degrees, 1 minus 1/2, 1/2 of gravity times 500 squared over b0 cosine of theta 0 squared. Now over here, let's just be careful with the angle over here. Remember that according to our frame of reference, y is going to be negative, x is going to be positive, so we are on the fourth quadrant over here. So that means that the value of the tangent would be negative tangent lower than 0. So that means that we need to take, instead of the tangent of 60 degrees, we should take the tangent of 300 degrees for everything to match up. So over here, now my equation becomes, instead of tangent of 60 degrees, just to take into account the proper quantities, it should be tangent of 300 degrees, which is the same value just with a negative sign in front of it. So with this we get the sum of the values over here is minus 766.025 plus 1/2 of g 500 squared over b0 cosine of theta 0 squared. We're going to solve for b0 cosine of theta 0. So first step, 5 is going to be equal to, well, multiply this by 2 divided by gravity times 500 squared, and this would be equal to 1 over b0 cosine of theta 0 squared. So just to get rid of the squared, let's take the square root. So this is going to be equal to approximately 0.025, and thus b0 cosine of theta 0 should be equal to 40 meters per second. So now let's take this result that we got for solving this equation. Notice that we have this value, but we still need to know the magnitudes. For that, we're going to employ the calculation for the final time. So the final time is going to be equal to 500 over b0 cosine of theta 0, which is going to be equal to 12.5 seconds. We're going to use this time in order to know what should be the value for b0 using the equation of y as a function of time. And additionally, we're going to use the equation that we found for tangent, this equation over here. Since we already know the final time, we can know what is going to be the value for theta 0, since we know b0 cosine of theta 0. So let's repeat equation 3. We know that tangent of 60 degrees needs to be equal to tangent of theta 0 minus gravity time final over b0 cosine of theta 0. To final over b0 cosine of theta 0. So that means that tangent of theta 0 is going to be equal to tangent of 60 degrees minus gravity time final 12.5 seconds over b0 cosine of theta 0, which is 40 meters per second. Again, to be consistent with all of the quantities, this tangent should be tangent of 300 degrees, as I mentioned before, instead of tangent of 60. So we're going to end up with, this would be equal to minus 4.797676 approximately. Thus, theta 0 would be equal to arctangent of this result, which is actually over here. I oversaw that it is easier to get the result directly with tangent of 60 degrees. The equation is going to be quite similar, but one step before, just to give us the correct result. So essentially what we're going to do is find the initial velocity on y, this factor over here. So we're going to get b0 sine of theta 0 minus gravity, the final time that we just got, divided by b0 cosine of theta 0. So that means that b0 cosine of theta 0 times tangent of 60 degrees, remember that all of this factor is 40 meters per second, plus gravity times t final, is going to give us b0 sine of theta 0. So all of the left-hand side gives us, taking into account again that this should be tangent of 300 degrees, just to keep everything consistent with our calculations, gives us that b0 sine of theta 0 is equal to 53.3429 meters per second. And now, with this information, we can calculate theta 0, which is going to become arctangent of the initial velocity on y divided by the initial velocity on x. Why is that? Because these are the two corresponding values. Remember that b0 cosine of theta 0 is the initial velocity on x, and this one would be the initial velocity on y. You can also do it algebraically, b0 sine theta 0 over b0 cosine of theta 0 is going to be tangent of theta 0. B0 and B0 are going to cancel out. So if we take arctangent of this quantity, it's going to give us the result. So the result for this is going to be 53.3429 over 40 arctangent is going to give us that theta 0 is going to be 53.135 degrees. And you can cut up to the number of significant figures that you require. And finally, we can calculate B0 from either of the equations. So let's find B0 from the equation on X, which is going to be starting from B0 cosine of theta 0 is going to be equal to 40 meters per second. We know that B0 would be equal to 40 meters per second divided by cosine of theta 0, which gives us 66.67 meters per second. You can do the same thing on the Y just to validate our result. It would be dividing the velocity on Y over the sine of theta 0, the sine of this angle that we just found, and you're going to get the same result, 66.67 meters per second. And you can cut up to the number of significant figures that you require. So over here, this is going to be our value for B0. This is going to be the angle at which we need to throw the projectile at. This would be the final time that it would take for us for the movement to occur, and this would be the initial velocity on X and the initial velocity on Y that we are going to have. And with that, it would be all. Thank you very much and have a good one.